All right. This is a little bit more technical, a little bit more geeky. Who here feels really confident with powers of 2? Because if not, yeah, you might be in a little bit of trouble. IPv6, introduced in RFC 2460 in 1998. That's right, 98. It's been around for a long time. V4 is 32-bit. What's 2 to the 32? Quickly, approximately. 4.3 billion, that's right. IPv6, what's that? 2 to the 128, that's 340. What does that mean? Who knows? It's a really big number. It's 4.3 billion times 4.3 billion times 4.3 billion times 4.3 billion. But the last 64 bits of an IPv6 address are the host identifier, which you can think of as like a MAC address. That stuff's not routable, right? So that means that for a routable IP address, you get 4.3 billion times the size of the current internet number of devices. Seems kind of wasteful, but it's the way it works. So V4 refresher really quick, right? 32 bits. We take 8 bits at a time and represent them as an octet, right? So it's a number 0 to 255. 4 bits is a nibble, right? Which is 2 to the 4th values, which is 16 values, which happens to be 1 hex character. So V6 represents addresses as hex characters. So it breaks out the 128 bits into bytes of, nibbles, right, every 4 bits. So a V6 address looks like that. It is long. So when you have an address like this, one of the things that you can do is you can leave off leading zeros. And then you can, if you have strings of consecutive zeros, you can put colon, colon. You can only put 1 in an IPv6 address. Otherwise, it'd be non-deterministic what the length of the 2 sections were. There is no such shortcut for Fs, which is rather unfortunate because F occurs just as often as 0, 0, 0, 0, 0. CIDR works the same for V4 and V6. When you see an IP address followed by a slash and a number, it means that the first 36 bits in this case are significant, right? Which represented in color is easy enough to think about. The purple stuff is significant. The white bits, the black zeros are insignificant. URLs. Let's talk about URLs, right? Everyone's familiar. I'm not going to go over the protocol, the host name, the query parameters, all that stuff. Just like you can use a host name, you can use an IP address directly, right? Most everyone in here is a developer. They know this. The port, right, defaults to port 80, so you don't need to specify it. Now, who sees the problem with IPv6? Right, exactly. So if you put a V6 address, you have to put it in square brackets. No, even if you're not specifying the port, because it wouldn't know if you were talking about the end of the V6 address. So if you have a V6 address and you're putting it directly in there, you always have to do it. I already mentioned this in the earlier talk, but one of the differences is that IPsec is mandated in V6, whereas it's optional in V4. Your operating system, unless if you are using something obscure, supports IPv6 already. The amount of internet traffic that's going over V6 native is really, really, really small. And another important thing to remember about V6 is that there's no interop with V4, right? So they're completely separate networks. There's an IPv4 network and an IPv6 network. So in order to get from here to there, we need tunnels, right? There's 6N4 and Teredo, which is Microsoft's tunnel. This is a diagram from Teredo, and it shows very nicely how the V4 internet and the V6 internet are completely separate. And this is one of the reasons that slowed V6 adoption in a massive way. I already showed the A and Quad A records in my talk earlier. I just wanted to include them in the slides for completeness when they get uploaded later. And I'm actually done ahead of time for probably the first time in my life. Yes, Jeff? What happened to V5? Actually, there is a V5, there's a V7. V5, they all existed as standards in academia and stuff. Just turned out that there were some fundamental protocol flaws and it got thrown out, and V6 turned out to be the better alternative.